Hey there, hi, you. Yeah, you. How you doing? Never mind, I don't care because I can't hear you. What you should care about, if this is your first time here, is who the hell I am. I make YouTube videos, but not really. They're just Twitch VODs, so you should catch me live, like I am right now, okay? And all the VODs, if you can't catch them live, go up on YouTube, so check them there if you're not into the live thing. But I'd like for you to come say hi. I work on things like an OS and a compiler and a language and a lot of things like LaTeX and just things for fun, floating point, syntax highlighting, a text editor, things, that you do. Hi, is it Yush? How's it going? But yeah, I do a lot of things. Go do all the things, fork all these, clone them, build them, if you're interested in these programs, and subscribe on YouTube, follow on Twitch, click all the buttons. Most importantly, I have a Discord, and this is where you can join. You'll show up in the welcome section here. You can join, be a part of this wonderful group of people. We're all programmers. We like to have a good time, and we like to have a very good time. So come say hi. You can get help and get announcements every time I go live, like the one I'm about to write right now. Is it use? Oh, says good. I had a 6-hour meeting today. Oh, rip. It's amazing you're still good. Is it Yush says, how about you, Lance? I'm doing okay. I thank you for asking. I appreciate it. Is it Yush? I am doing okay. There's our little announcement. We are now officially live. And we should get started on what we're doing soon. Speaking of what we're doing, hey, Bitstream Eyes, Lander says, fun fact, I exist. What's up, Lander XD? It's been a while since you've been around here. Aletri says, hola. What's up, Aletri? How's it going? I think we can just get right into it. I don't have anything crazy to planned. We're going to implement return, I think, in today's stream, or intercept, the programming language and compiler. How about that? I believe it's in the to-do somewhere. Yeah, early return, parsing, and return block in the IR. Izidiyush says, and I turned 19, man. Happy birthday, Izidiyush. You're so old now. Ew. What's up, Bitstream? How's it going, everybody? Thank you so much for tuning in. I appreciate it immensely. Immensely? Izidiyush says, thank you. No problem. I'll call you old any day of the week. It's probably a belated birthday. It's a little late. So I think we should just get right into it. We probably need to start in the parser because in our IR backend, we already have a return keyword. If we take a look at just the output of compiling something, let's get this kind of working again, I guess. Yes, but not all this. Something like this, and let's print the IR out. This should probably change to print IR. If we have print AST, we should probably also have print IR. But debug IR prints it multiple times, so maybe print IR should just print it once. I don't know. We'll think about it. And we got to feed it something, some sort of file. Let's look in examples, and let's just do a simple like gcd.int. Is that not a file? Is it greatest common denominator? Okay, it's spelled out. Perfect. That's all I needed. As you can see, there's a return instruction in the IR used at the end of functions, right? So all we have to do really, I mean, technically, is just wherever we encounter a return keyword, insert this. But as soon as expressions come into play, it gets more complicated. So let's think about how this can work. Saraid says, yep, what's going on, Saraid? How's it going? I believe we need to add a new keyword, which means in the AST file, we need to add a new token type for it. Somewhere. Here it is. I'm too low. And then just up this to 11. Pop return in here. Saraid says return expression? Like the expression of a return. Yeah. Hells151 says hello. What's up, Hells? You asked an amazing question in the Discord. It made it pop off this morning. Well, we've parsed token, we've lexed now token return. So now we just need to parse it effectively, right? And that's going to be in parse expression with precedence. And this is going to just be a keyword like for and such right here. Whoops. There we go. Nix Craig, hello. What is going on, Nix Craigie? What am I doing now? What do I actually need to do? Well, we need to create some sort of AST node that returns. Is that true? I feel like that's true. Because if we don't have it in the AST, I don't think we can represent the full program, which means we kind of need that in the AST. So let's look at the AST nodes. Do we have a node return yet? We don't have a node return. I think we're going to need a node return. And then we're going to need a node return struct. And then we're going to need to add this struct to the node tagged union, basically. And this is just going to need expr. We'll do value. Why not? And now I need to find a node and add node return. And I'll just keep up the tradition and add an underscore. How about that? How about that? Sorry, it says sounds about right. Legendary. So now we have a return node, an explicit return node. There's also implicit returns, but now we have an explicit AST return node. And we should probably do something like this to create a new return expression. Sure. That's not really how that works, but sure. And this may be null. Perfect. Not perfect. Okay, what are we doing? I'm just going to copy this little bad boy to create a node, but it's going to be a node return in the AST with the given source location, and we're going to return that node. Then we're going to say node value equals a given value, but that's going to be the return struct. Alrighty, if anybody has any questions, by the way, let me know. Let me know. So, okay, we have node return now. Let's just see what happens if we do an example. I should probably write a basic example, I guess. Load the editor for NTS mode. NTS mode, okay. And basically, we're going to write a function which returns an integer 69. I think this is fine. I think this is a good start to test that this returns 69 instead of 42. Let's try it out. Nashiora, a new compiler stream just dropped. You know it. Exhaustive handling of token types in token type to string conversion. That makes sense. Where is that? Parser.c 1508. Beautiful. What's up, Nashiora, also known as Local? Suraid, since you're asking about the absolute headache that is instruction encoding, are you planning on adding an object file backend anytime soon? Maybe. Perhaps. Well, it compiled. Which is kind of interesting that it compiled. Did it compile? Not echo that. It's this one. But now I gotta do this. Okay, it did compile, I guess. What's in code.s? I'm kind of scared. Okay, so no code got generated. This is still GCD Euclid. So if I did -v, well, it says it generated it. Am I just, oh yeah, I'm very smart. There we go, that's better. Left-hand side is null. Wonderful. In the parser at 1391. Oh, I know what I did. I know what I did. That's a good assert, by the way. This is a very good little ice we have. Yeah, compiling the wrong file would do it. Yes, maybe. I didn't do this, so we were just breaking out of this. And then, here's the thing. We're gonna yeet return. It's Audi here. Audi 5000. But then I would like to parse. Yeah. So we need to save the source location of the beginning. It's very similar to a for node up here. We need to save the source location at the beginning. Technically, we only need to save the beginning because we'll just be updating the end. You'll see how this works. Nix Craig, I think you should just make the return keyword be yeet in intercept. PR's welcome. So then we need to say if p talk.type equals token semicolon does not equal that, then what we're going to want to do is actually say node pointer expression equals null, expression equals parse expression. I don't think it's expression, it's expr, isn't it? And then we just pass in p. And so what would this look like? Return, or return 42 plus 89 over 5. So if we have an expression, do I still want to enforce a semicolon? I kind of do. I don't know if that makes any sense, but I feel like having a semicolon after return every time kind of is the way to go about things. Sfred says, yeah. So then at this point, I get to do this check again, but this time it's an error. Not confusing. Can I do arr@? Do we have that in this one? We do. And then we can do p.toke.source location. And then say semicolon expression terminating operator semicolon is, oh, this is off the screen, is required. Sraid says, otherwise you will run into horrible situations like if a return new line foo, which will be parsed as return foo. Oh yeah, that'd be horrible. That would be horrible. Expression terminating operator is required after return keyword. Sure. This might give a little bit of confusion because after the return keyword, there might be an expression and the semicolon needs to go after that. If anybody knows how to word that better error message there, that would be wonderful. And then we can just pass in Esper. Does this parser have at start of expression or something equivalent? I don't think so. Nope, nothing like it. Expected semicolon or expression. I think that's just kind of hard coded into the parsing here. That would be that. So you're saying that we would take this, like these three, and then go from there, like make that a function and have it return the expression node? But then, yeah, because we don't require the semicolon, so it gets rough. No, not really. Yeah, so what you're talking about is kind of bitstream. Ooh, with an error message. Fantastic. ... is required after return expression. Okay. Cool with me. Interesting. I did not next token. My bad. And then I think that the end of this we need to save. Invalid node type in the type checker. Pog, we made it. Expression terminating operator blah is required after return expression. So maybe this isn't like, what if I just did that? That's probably more readable for like a human being that isn't a compiler dev, right? When they read, oh, I need a semicolon. Like, I don't think they need the craziness in front. Cool. Cool. And in the type checker, this is where we get to do fun things, like make sure that, yeah, this is where we get to do fun things, like make sure that a return expression, if it's within a void returning function, doesn't return an expression. Doesn't have an expression. So this is going to be stuff like that. That's going to be fun. Let's just jump to node 4. And right after that, looks like, nope, not there. Looks, oh geez, don't be doing that. Node return, okay. So can we get the function that this is within? Do we know that at this point? Do we know what function we are within? Is it context? What is it called? We just have the AST. We're not code genning yet. So we have the AST. We have functions. So which function do we happen to be within right now? What do we provide? We do type check expression, so we probably type check the root node. I don't know if we keep track of which function we're in while we're type checking. That might be rough. How would we know that? We'd have to set that anytime we're declaring a function. And we'd have to assume we know its return type. There's two ways of finding the function. Keep track of the current function in the parser and store it when you create the return expression. 2, go up the tree until you find a function node. Does that work? Interesting. We looking at the same thing? What in the world? I don't think AST.c knows how to handle return nodes. Why does it not scream at me? Where would this be? Well, I'm gonna add it here. And then I'm gonna go to the top here and put a static assert. We don't have a node count, do we? Oh my. Okay. This is happening. What is it, 17? What is this? It is 17. That was a good guess. Handling of node types in AST replace node. Sure. Okay. Give me another. Where else are we? Do we have node 4? We have it in here. And we have no static assert. Wonderful. While printing AST nodes. Legendary. It's gonna steal while or something. Call this return. Source location start. AST print children. Return expression. Value is what I called it. 1, but we're only going to do that if it's a thing. I guess I didn't need braces, technically. Sure. Hmm. We got to an unreachable somewhere. If node return value. Why is this screaming at me? Did I do anything crazy? I don't think I did anything that crazy. What are all the warnings? Node return not handled in switch 716. Okay. Okay. Exhaustive handling of node types. And freeing AST. Unrelated, but would you say that tree sitter parsers in general are as janky as tree sitter CPP? No. Tree sitter CPP has like undergone major changes like 4 times. I think it's just a mess. Like the C grammar hasn't changed that much. the C++ grammar, I feel like it changes once a week. And like majorly, like, oh yeah, we don't have those nodes anymore. Now that these nodes are like this, now this is a different thing. You have to change your queries constantly. It's a mess. I don't think we just have, do we already handle all the children? For all the nodes, I mean, there's nothing we have to do. The expression node will also be there. So I think we just add it here. There's nothing actually to free because the node that's within the return will actually, yeah. Okay, well, just as confusing, but we're getting there. Node count is now not handled in the switch, which is, I guess, something I have to do because reasons. I could just do default break. Yeah, I'll just do default unreachable. That should work. And then where was the other place? Probably the other place I put a static assert. Well, this place we have a default, so it's not there. Where else are they talking about? 1172. The replace node thing. I see. Sure, I'll put that at the top. Default unreachable. Okay. Still very confusing. There's supposedly supposed to be a declaration in there somewhere. It's a very confusing AST. Did I screw up the parser that bad? What have I done? I really don't know what I've done. I need to do this. Okay, no. Just checking. Well, this one, interesting. So parse expression should leave us on a semicolon, or we should just be on a semicolon. Either way, we need to call next token and pass the semicolon. And then probably get the end and then do the thing. I still don't know why it's not printing anything out. Because there should be more nodes than this in the AST, as far as I know. That's what this left-hand side equals thing should do. Huh. Expected expression got semicolon. Yes. Because we didn't move past it. Huh. Maybe let's try simplifying this. Like that. Okay, no. Can I go, just give me a 69 with no return. It's still kind of funky. This AST doesn't look right at all. Even with syntax only, it should be more than that. That's really weird. I don't get that. So where does the function definition isn't in the AST? I'm not getting that. Temsira, first time chat. Hi, Lenzer. What's your take at getting into programming for a semi-beginner? My take? You can do it. Write code. Write a lot of code that you're motivated to write. I think that's it. That's all I got. If you have specific questions, I'd love to help. Semicolon is required after return expression. I should probably highlight the return expression, not the thing I just got. Yeah, that kind of looks better. Also, I think I need to do this ordering. Yeah, that's better. And then this. Technically, that only needs to happen if this happens. Yeah. That's exactly what that does, yeah. I don't know. Let's try out, if we do it no matter what, then it's going to move us past return as well, yeah. So that's the same. It just hasn't, well, it may have changed since we needed return. We're at the end of whatever's next, which is meant to be a semicolon. Which should, yeah, that should probably happen after that. Because then it's going to give us, is required after return expression. It'd be nice if we could put it here, but I mean, what are we going to do? That would require a different error here and here. Because after we parse this expression, then we would need to set it to parse beginning. Well, let's try that. So else we do the end. Start, not beginning. Kinda. Right? Should it be the end before? I don't think that's right either. It should be the end before. So if I do it before, yeah, right after I do this. I know this is a mess, I'm getting there. It will clean up, I promise. Tamsura says, okay, and what languages should I learn? Anyone you want to. I have studied Python before and made some very basic projects, calculator, graphs, charts. I like the simplicity that Python offers and haven't really tried any other language apart from it. Well, I'd say you have to find what you're interested in. I'm interested in like low-level stuff. I did like electronics for a few years and I learned how to make like, oh, this is how you make an adder from NAND gates only and stuff like that. And I built those circuits with like little chips and had fun on breadboards. And then when you're doing that, it's kind of like, well, how does this actually work to create a computer? You kind of start getting confused. Like, all I can do is add two numbers. How do I actually, like, how do computers work? I mean, all they do supposedly is add two numbers, but they're pretty fancy with like what they do today. So then it was just kind of a goal of learning how things work and stuff like that. And I learned C and low level stuff and how to deal with assembly and registers and memory addresses, and learned the computer architecture and everything like that, how the CPU itself works. And all that I did basically while writing an OS for that CPU, which helped a lot. So just find something that's fun for you and do it all the time. That's how you get better at it. I mean, that's kind of how you get better at anything, right? Like Tony Hawk just really liked skateboarding and he did it all the time. And then he got really lucky and he happened to be like the best skateboarder of all time. And really lucky and famous and everything like that, right? But you don't have to be famous to succeed. So token return, we now set the return expression. We have a proper error message, or somewhat proper. So now if I put that there, it should just work. But then we get a seg fault. Wonder if I should, yeah, let's do that. We're gonna go to Ubuntu. I had a panic that it was gonna show my IP like it does sometimes. It didn't, luckily. Programming, Strima 2023, intercept, Ellis, build, where are we at? We're in WSL, build WSL, do a reconfigure or whatever. Reconfigure, build, and then use int c from that to do exactly what we were doing before. With examples / early return.int. Temsira says, thank you for the kind advice. Really appreciate it. No problem. I'm glad you enjoyed it. Temsira, thank you so much for the follow. And Crouch. Very cool. Okay, so we have a segmentation fault in type check expression. What did I do in the type checker? Oh, I did do a bad thing. No break. That makes sense. Could have seen that one coming. I'm surprised that compiled. It was just lucky. Anyway, we want to return true. That's why we didn't have it, because we're supposed to be returning things. But we want to first of all say if, what is it called? Expression. If there is a value and it fails type checking, it doesn't matter what's going on, then this value fails type checking, and we should report that error, I think. What do we pass to type check expression? What else do we need? An AST. Of course. Then this is going to be an error with the value of the source location. The value of the source location. The return value source location will be where we want to point people. And we should say I mean, really, we should, since we're calling type check expression, and it should be another expression error and not the same one, then we should technically just return false. Because if it's another return that has another value that then fails, at some point there has to either be an expression or not be one, right? Be an expression that fails or passes, or not be an expression, which means it passes. Does that make any sense? Because it has to be some other sort of expression that failed for some other sort of error that will have already been printed out. Hopefully. Peppertilly and Prolonosk997, thank you so much for the follows. I appreciate it. We're almost at 500, but right now we're at 469. Ayo! Oh, PogChamp. Right? So that's something we can do there. To do, ensure return nodes within void return type functions have no value. And we should probably do this before this so that an incorrect value is less important than there just not being, like, the presence of a value. The validity of the value should only come into play if the value is able to be there. But if the value shouldn't even be able to be there, that's kind of more important than the validity of that value being there. Ensure return nodes within void return type functions have no value. So Suraj said we could keep track of it in the parser. Do we know what function we're within in the parser? We have a Boolean in function, but do we know which function? I don't think we know which function we're in. At least not easily. So if we think about type null of function body is not convertible to return type integer. That's a good point. So in the type checker, we're going to have to set the expression type to whatever the return value expression type is. Which means we're going to have to do this sort of thing again. We don't even need this. We can just do this. Else. Yeah? Okay, so we set the expression type based on the return value type, or to void if it's null. We could probably do this with a ternary. Hold on. So if value is not null, do that. Otherwise, do void. Okay. Suraj says we can just add that then. Okay. Unrecognized expression kind. Hey, we made it to CodeGen. How about that? And we can now see an AST with our return in it. We have return the literal 69 in a block for a function. PogChamp. We should probably have a pass in Sema that removes blocks that are just one statement. Something to think about. And then in AST, I just thought of something, AST.c. Here, we should be printing the type like we do here. Because I think the type of the thing matters quite a bit. Perfect. It's interesting that this became an integer at some point, but this didn't and this didn't. Okay. So if we don't, we can add that. So you're saying in the parser we can add that, because how do we do this? In the actual parser struct, we're probably going to need to add a function like this. I think this makes sense. And then we could also do a type. I don't know if we need that though. So it says sure. Okay. This will work. So we have a function and say oh, this goes well right here. The current function, if we are within one. Okay. In function, in parse function body, we say function equals true. We don't actually have the function here though. So wherever we parse function body, interesting. So we don't have the function node until we have the body, but we don't. So what do we actually need? Maybe the function type. Because we have a function type, but we don't necessarily have a function node. It would be nice to have it. I guess we could pass in null for a body and then do like that. Maybe that's how we do like. Params. Because that's going to be quite important when making the function, I feel like, is having the parameters. This is difficult. This is difficult. So yeah. Stay hydrated, by the way. We kind of need to reference, we have a chicken and egg scenario here. We are parsing the body of a function, which means we haven't yet parsed the function. When parsing return expressions within the body of a function, we need to know which function we are parsing. Are you wearing programming socks and drinking Monster right now? I'm drinking water. And I'm wearing Walmart socks to answer your question. Sure would be nice. Sure would be nice. So this is after type checking. Can we look at before type checking? See, this is what I'm worried about. If this is the AST before type checking, the return isn't in here, right? Oh, that's kind of good. This is good. So because the return isn't in here, then that means that everywhere we see a return node in the AST, we can go up and find a function node, and hopefully that should tell us what the return type is. I think we're gonna have to do that. I don't think we're gonna be able to do this, like, add it to the parser thing, at least not right now. Which means that in the type checker, we're gonna have to do like node pointer func equals expression parent, and then while func kind does not equal node function, func equals func parent. And then we can get the return type of this, which equals func function. I don't even know what I'm being recommended here. Func function. What has the return type? Is that the body type? No, it's not going to be the body type. It's probably going to be the type. It is probably going to be the type because the function type has the return type. And then this thing is what we're going to need to make sure and say if the function return type function we are returning from. Right. And then if the function return type is equal to void and we're checking for the error case, so it's going to be return has a value. It's not any braces. Then we can error out. Jesus. Okie doke. I'm pretty sure Twitch just gave me like 5 notifications. I have mobile live dashboard like 5 times. I'm pretty sure it was just beeping until I looked at it. This is crazy. Swipe away. I think this is, yeah, this is the way to do things. And in the future, it would be more efficient to cache function type in return AST node. Just while parsing. Just gonna mention that. I don't think I'm gonna do that right now. So we have an error. Where necessarily is this error? This error pertains to this value very particularly. And it's basically saying return expression. An expression must not follow return in a function returning void. Okay, sorry about that. Just had to answer a text. So where are we at? We get the function we are returning from. Yeah, cache it or whatever. Return type functions have no value. Makes sense, because if there is a value in a function returning void, and we're in a return, then there shouldn't be. And then this will return false. Then this will, if the value doesn't pass type checking, it will return false. So we're gonna I don't think I'm going to refactor it. I don't think I could change it so that like these expression return value checks are one check. But I feel like this makes it kind of more easy to understand what's happening. Because we could make this one if and then have each of these be an if inside of it. But there's still two. In fact, it would grow the amount of ifs. There'd be 3 ifs. I don't know if that's necessarily better or more readable. So we're gonna continue on with this. And then this could also be within that if, I guess. That is something to think about. Okay, so now let's try and make a little test, I think, and we're gonna do return early return, which is void. Early return with expression but void. Perfect. And we're gonna say foo returns void. And we're gonna try and return 69, call foo so that it gets used. And there should be an error. We can't return an expression from void. And I'm gonna have to do this myself. An expression must not follow return in a function returning void. Legendary error. Okay. Legendary error. So that works. PogChamp. We got parts of it working. Expression type, blah, 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 blah. Okay. Yeah, this should be good. This should be good. And now, I think it's just going to be the actual code gen handling, much like here. This is going to be somewhere where we handle all the nodes. CodeGen Expr. Where is it actually defined? Here it is. Nope, that's not it. That's the forward declaration. Where is it? Am I great? Am I blind? Didn't see it. Is it not in this file? Okay, here it is. Jeez. Don't know why that was so difficult for me. G-bus. We're missing another little thing here, I noticed. Exhaustive handling of node types during code generation. AST to IR. There's node 4 for you. And I think at first we can kind of just do something like this. Uh-huh. And then we can use its IR. Yep, just that IR. And return that. Radaluca, thank you so much for the follow. I appreciate it. 471. Assertion failed last and last IR. Okie dokie. What's happened? What did I do? Cogent expression, IR return. So does IR return actually close a basic block? That might be an issue. What am I doing? Intermediate representation. IR return. Ret is a terminator. Yeah. Yeah. So do I make a new basic block and put the return in there? The value and the return in there? And then create a branch to that? That's got to be what I have to do, right? I've got to create a new block. I could also, I guess, have one return block with a phi node that all of the return statements or return expressions are an argument of, but that kind of seems complicated right now. Return block. We're going to want to attach this block. Do we need a new block? I don't think we need a new block for the return. We may just be able to put the return as the terminator for the last block instead of branching to this block. Because we need to do a branch to the return block. But then this value isn't in the, yeah. We kind of need to do that earlier. This is difficult, I'll give you that. So we're like in the middle of a basic block. X. And then there's like instruction 0, 1, 2, etc., right? Well, not etc. We're on like instruction 3, and we know that this is like add, this is like sub, this is move or whatever, but this we don't know what it is because we're generating it right now. And ideally, there'd be a terminating thing somewhere that, can we just return? If a basic block, yeah, we can just return from the basic block. I don't think we actually need to branch to a return block. I think we just need to cogen the expression and return. But then we need to create a new block after this, as far as I know. And then this is going to be like after the return everything else. And it will end up terminating itself, as far as I know. So when we attach the block, we're saying like insert new instructions into this block. Let's think about that. Last and last IR, still not correct. Cogen 388. Let's just go check what the hell it's talking about. In a block expression, it's saying if not type is void expression type, assert last and last IR. So we didn't set last IR in node return. We didn't set the IR over on the expression, which means it was never set. Okay, that's better. What's the IR look like? Perfect. I think that's exactly what we wanted, actually. I do believe it. Saraid says, I'm fairly tired, so I'm going to go to bed now. Laters. Thank you so much, Saraid, for hanging out. We appreciate it. Thank you for hanging out, helping out, being a part of the Discord all the time. We love you around here. You have some good sleep. You deserve it. For me, it's like midday. Do we need return here? Why are we returning here? It's a little odd. Maybe we'll do it here too. Keep up the weird tradition, huh? So because, yeah, we can just return from something. I don't know if it should be an error necessarily. Bitstream says, for me, it's already past midnight. Yeah, I think you're literally on the other side of the world then. It's currently that time for me. Right? 2:23 in the afternoon. Siko says, same here. First time chat from Siko07. Thank you so much for the follow as well. 472. Yeah, thank you. If you are new around here, be sure to check out the Discord. Join it. You will get announcements every time I go live. And if you ask to be in the notifs group, you'll be pinged. I also have a YouTube where I upload all my VODs of every stream I ever do. This is part 53 of a playlist for compilers, not compilers, a compiler that I've been working on. And there's a whole bunch of parts if you want to go check those out. So I really recommend that. And it's all open source on GitHub, so be sure to check it out. Am I playing in the background? I am. Anyway, yeah, be sure to check it out and clone it, build it yourself. All you need is a C compiler and CMake. It's really easy. And not even a recent version of CMake, 3.14, which is like 5 years old at this point. Coolio. Now return generates things, which means that it's working. We're getting all the way through to the back end and generating code. So if we actually compile this code and run it, and then check our exit, oh, we returned 69. So normally without early return, not here, here, without early return, 42 would be returned, right? So let's make sure that case works. So you can see that we would normally return 42. But because of early return now, we can return 69. As far as we know, right? Pog, 69. So now we have early return. It's working. It's not perfect early return, but it is working. There's probably a more efficient, a more space efficient way to do early return, where there is only one return block per function. It houses a phi node, and each of that phi node's arguments are the values that may be returned based on the basic block that is jumped from. Yeah. And then if we did something like DCE by allowing optimizations to happen, okay. That didn't work. Cannot remove used instruction. So there's something most likely in the optimization that doesn't understand return. Let's look at the optimization. It's been a while. We should probably, so we do static assert here. So IR return. I'm sure we're just checking that yeah, I see. So we're probably trying to remove a return instruction, which there's supposed to only be one of in a basic block. So we may actually be trying to remove, well, it's saying trying to remove used instruction, which doesn't make sense. Did I forget to mark uses? Is that something I did? So let's check that IR return marks uses. I was just there. IR return says if return value mark used, return value branch. So that does mark uses, so that should be fine. Then we start a new basic block and continue. I kind of want to see the backtrace. That'd be nice. Did I put clean first? No, okay. It didn't crash, that's good. So now I can optimize. Where is it actually crashing? In build dominator tree. We're trying to remove and free an entire block. So maybe this is DCE. Well, no, we shouldn't be doing anything. Why are we removing something when we're building something? Hold on. So we need to build the dominator tree. Yes. Is that in DOM? Cogen DOM? Cogen DOM. Okay. Sika says, nice, I'll have a look at the repo. Legendary. Build dominator tree. Why are we... Okay. Remove unreachable blocks and free vectors. So delete reachable, delete blocks to remove. After removing all the blocks to remove, the blocks to remove were gathered by looping through all the blocks and saying if it's not reachable, then remove it. And we collect all the reachable blocks by determining all reachable blocks from the entry block. Okay. So when we IR remove and free a block, why are we not able to do that? We're calling IR remove, and then 105. Okay, so in IR remove, we're then getting to cannot remove used instruction. Which instruction is used that we're trying to remove? Which instruction is used that we're trying to remove? Remove it from the block. So remove all instructions from the block. So we're saying while block instructions first. If it's a phi, then remove phi arguments. Otherwise, just remove the first from the blocks. Shouldn't we be doing something like this? Well, no, IR remove is probably handling that with list remove. Maybe? Look at utils. In vector? It's in vector, okay. So a list, I'm pretty sure is just something that has, yeah, a first and a last, right? And these are list nodes with previous and next pointers. Cool. So when we list remove, we say if element previous does not exist, which it would for the first, it wouldn't for the first, then we reset the first to the next element. Okay. That seems to work. So if we're setting first, where were we? Yeah, if we're setting first, yeah. So what are the users? We set func IDs. We f-emit the instruction that we can't remove. We say in function, emit function. I don't think any of that happened. We have cannot remove used instruction, but then it never returns. Is it just above it and I'm dumb? Yeah, it's just above it and I'm dumb. Okay, and there's also no new line here, which there's definitely meant to be. Then I'd presume, yeah. This isn't really meant to be indented. That makes more sense. And then I don't think there should be a new line here, right? Well, there probably should be. That would make sense that this happens. And then in function blah. So we can't remove 2 because it's used by the return. Should we be removing in backwards order? Is that kind of weird? Let's try removing in backwards order. Hey, haha. Oh. Unid, I don't know how to say your name. Unidas3, thank you so much for the follow. Be sure to check out all the links down below. All of them. Alrighty, coolio. So yeah, it's now working optimized. It looks like the issue is that we had a problem removing entire blocks from the IR, which isn't common, or at least probably never happened up until this point, because there was no way to cut out entire blocks of the IR and make them unreachable, at least from the code generation standpoint. So at this point, you can now see that we're detecting these are all leaf functions and also pure functions. Excuse me. So you can see that we have the main function takes 2 parameters, and it'll just tail call foo, and then that will just return 69. And you see the return 42 is nowhere to be found. It's been optimized out. And if we take a look at code.s, you can see it's quite literally, it's very simple, right? It's very simple. And this will be quite an optimized program. Pretty soon, I'm going to work on function inlining. And I want to make it so that you can pass a flag and every single function will be inlined into main as far as we can. Because I'm pretty sure you can replace recursion with a jump to a label, right? So if you just keep making labels underneath main, you can just keep having every function inlined. And the code would for sure bloat, but it would also, it might be really fast. Especially if you can then optimize after doing all that inlining. But then it's a register allocation nightmare. So, you know, you win some, you lose some. But yeah, as you can see, this is a pretty simple program, and it does work. Hopefully this also works in Windows. Yep. And make sure it still returns 69. It does. That's legendary. Cool. So you could now, if you really wanted to, you could simplify, not simplify, but make this different. I mean, I guess you already could. I mean, this is technically only one expression because it would just be a return statement here, right? And then this would go at the very end. So it's kind of tricky there. How are we doing as far as tests? Maybe this should be a test within itself as well. Just copy early return into tests. And now let's run all the tests. I think just ctest for now. Looks like the 5 failing tests that were failing last stream are still failing. To be expected. Perfect, but none of our early return stuff. It looks like they passed. Poggers. Sorry, unimplemented. Handle argument on stack that is not lowered to a point. That's right, the MSWin calling convention thing. That's right. Maybe that's something we can work on right now since we just kind of pogged out early return. We still want to do return block in the IR, so I can't say we're necessarily done with early return. I'm going to say each return has its own return instruction. We should alter this so that there is one return instruction and a phi node with arguments of each return, of each possible return value, return expression. Sure. Gulio, Julius Ever, thank you so much for the follow. I appreciate it so much. Let's think about how we can commit this stuff. Oh, also, I apparently didn't merge this. Lol. So in the type checker, we just added node return. Okay, so let's think about, we have node return and count and everything. Token return. Let's do token return. Let's see if we can just get the token stuff, huh? That's all AST stuff. AST stuff. I even changed it more. Incredible. What's the point of having only one return instruction per function? Basically, yeah, it doesn't matter right now. I get where you're going with that. Right now, it doesn't matter. But let's say that we add some sort of like attribute to types. This may be a thing or something at some point. Let's say you have like my node type, right? And let's say you can say like it has a destructor, right? And it's like, oh, it has a destructor and this is defined like so. And then you just get a my node reference or something like that, right? And that's not on the right side. So imagine you have a destructor or something like this, and you say, oh, I actually want to like, I have a byte pointer, and I want to free that. And you're going to call free on data, probably as a void pointer. Well, not point, but benefit. Yeah. Oh, so to not copy all of deferred code multiple times. Yep, you got it exactly. So as soon as we create my node in here, then every time we return, we would have to call foo.destructor, right? Or destructor with foo, however we want to do that. And then at this point, it'd have to happen before this return, but then also this one. And that makes code size grow like exponentially for the amount of returns in a function. And if you have a function that has like a switch statement, not that we have these yet, so it doesn't matter yet, but if you had like a switch statement that looks like this, it probably won't even when we do get them. And then you're like, oh, I'm switching on 42 and returning 4. And then 69, I'm actually going to return 7. And then 420, I'm going to return 19. This destructor would have to be called within each one of these cases, and it just becomes an absolute nightmare. But yeah, hopefully that makes sense. You just don't want to copy the exit scope code a million times. And then in the actual generated code, you'll end up with like multiple places where you clean up the stack frame, but it's the same stack frame. And that makes debugging really hard when you can either clean up a stack frame from here or from here, but they both clean up the same stack. It gets messy, right? It just gets messy. Hopefully that makes sense. Anyways, we have tests passing. What was I going to do? I don't remember. I might today might be a short stream. We'll see how it goes with everything. X as void used to discard X. What if we enforce no discard on every function? That'd be kind of cool, right? I think that'd be cool. So let's think about how we could test that. No discard. Basically, we need a function. And this function, when we call it, can't be discarded. So this is fine. It's the return value of the program. This is an error. Its return value goes unused. And this should be an error, right? Because by default, we want functions that return a value to be no discard. So let's do a void function. So here's the other thing. This should be allowed if it's a void function as well. So discard function. So discard void function is what we're going to call it. Mancow, Temwile, thank you so much for the follows. First time chat from Brave Teddy. I tried implementing a B+ tree in C today and failed. Now I feel stupid. I feel you there, Brave Teddy. Oh man. If there's working on C and C++ and like low level stuff will definitely make you feel stupid. If you really want to feel stupid or see how I felt stupid, working on Mantissa is so embarrassing because all I'm trying to do is multiply two numbers. And it's like, I'm doing all this math and I'm like, okay, so if I do this, these are the bits, this is what this means. If I do this math in binary by hand, then maybe, okay, now I know the right answer, but what is actually the correct answer? It's 0. So how do I get to 0? And then I figure out, okay, how does the current code actually do the math? And then you do all the math in the current code and you're like, oh, that's not the right answer. That's not the right answer, right? So don't feel bad, Brave Teddy. I promise. Temwile is every time I program in C, I feel stupid. Exactly. It really just makes you feel dumb. Because you're like, why? I feel like I can multiply two numbers, but I'm not so good at it, apparently. Right? But the truth is, that's kind of just what C is. It's just that struggle of like, why doesn't this work? Why doesn't... Oh, it's because that isn't like that. Now it works. Brave Teddy says, sad part is, I don't think I'd succeed even in other languages. Yeah, sometimes it's not the language. B+ trees are kind of complex. Kinda. Yeah, they're very complex. And then I also tried doing a write-ahead log and pager at the same time. Well, there you go. Now you know why you're failing. Like, you don't just hop on a skateboard and go, all right, I'm going to drop in on vert. You got to, like, you know, step on it first and like, oh, can I actually stand on it? Can I push? Can I roll? Can I slide to a stop? Etc. Right? You got to do one thing at a time and slowly work on it until you can do it every time without thinking about it, and then you move on. So it sounds like you need to just start with a simpler data structure. Maybe try writing a vector or a linked list. Brave Teddy says you should implement a B+ tree and I'll watch and learn. I don't think I could. I don't know that. No, I did all that. Well, then I'd say do it again. Make it better. Go back to your old code and refactor it. Do something. You just need to stay at a lower pace before you get into B+ trees and write-ahead log and pager and Try writing a write-ahead log for your vector or a pager for another data structure. You shouldn't be jumping in with a new, right? On a project, you kind of want old, new, so that the new code can be tested amongst working code. So this we want to be fine and return 0 by returning some function that returns void. And it doesn't actually have to do anything, really. And then we can call foo twice, and this should not be an error because discarding void is allowed. Sure. And then I think we're actually going to have a failing one. As you can see, no discard function.int actually fails. For B+ tree, it kind of makes sense to use a pager. I agree it makes sense, and if you wrote a pager for some other data structure, maybe it'd be easier to write one for a B+ tree. Or try and write a B+ tree without a pager. It just, you want to reduce complexity, right? And it sounds like you're justifying complexity like it's needed, but it never is needed. You can always simplify stuff. It may work differently, slightly, but you can always simplify stuff. A hammer's just a rock. So this is not an error because we're not checking for it. So if we go into the type checker, I think we're already kind of checking for this in these places when we're checking for comparison results unused did you mean to assign. So it's this exact thing. If node does not equal vector back, so if it's not the return value, the return expression of the block, and if it's binary and blah, blah, blah. So if node does not equal vector and it's that, then it's an error. If node, so we should probably do this. And then we can remove this. Okay, so now in a block, if we're not at the back, if it's a binary equals, we'll say, did you mean to assign? I'm pretty sure you meant to assign. And then if the node kind is equal to a call, and node callee, I guess what is this going to be? It might be anything. So if it's a call, get function we are calling, which is the callee, and then it says resolve the callee. And at this point, it's already been type checked. So we know that it's correct. It's a correct call. So what is the call actually mean? What do I need to change about it? Why am I here? I need to know which function is being called. What's the easiest way to do that? It's kind of this mess, isn't it? It is kind of this mess. Okay, so the expression type gets set to the function return type, naturally. So the callee type function, that's a good point. So the callee has to be a function type, it looks like. So node call callee type function, ain't that a mouthful? Return type does not equal t void, right? So if the function being called doesn't return void, it is being discarded. So if it's a call and the called thing doesn't return void, and why don't we have attributes here? Where would the attributes be? It's not going to be on the type, is it? It should be on the type. Is this not the IR function? This isn't the IR function. Can we use the IR function for this? We already have. We know it's going to be an IR call, right? So like we create a call expression somewhere. This isn't code gen, that's right. So no, we can't use the IR. This is type checking. So I guess I just add a to-do here and say we should ensure the function does not have a discardable attribute. I could swear we have already have attributes. Maybe I'm crazy for function types. I don't think this ended up being used, by the way. It's in a node function. We have no mangle. So in here, eventually, in a node function, there will be a discardable. And that's what we should check here. We'll need to find the actual function node and not just the function type. This means following funcrefs. That's enough for me in the future. Put that into a reasonable size. And then this can just, I think, be air. Source location. And then this is just going to be, if the function being called doesn't return void, it is being discarded. Discarding return value of function. Non-void function. Discarding return value, a function that does not return void. I guess I could put the type it returns. And this is fine. You should be able to see by what the call is. So now, what if I run that myself? I didn't mean to optimize it, but that did happen. Okay. Now what's happening is that we did this for blocks, but we didn't do this. We didn't do this for... What just happened? I don't know where I just ended up. We did this for blocks, but we didn't do this for the root node, which maybe we should handle those in the same way or something, but it's fine. And then this can say comparison at top level, result unused, did you mean to assign using blah? And then instead of block children, this has to be root children. Error, discarding return value of function that does not return void. PogChamp. Okay, so now if we run our tests, should work. It doesn't. I broke a lot of things because puts and putchar. Oh, they return values. Legendary. Legendary stuff. Well, let's start with bug with not or something. So as you can see, putchar returns an integer. We're calling it and ignoring the return value. That's not allowed. So we're going to just say that it returns void. I didn't need to run all the tests again. That wasn't a smart move on my part, was it? Alrighty. I'm excited to start inlining functions. We did fix it. Okay, so now we can go to byte array. And in byte array, again, it's puts. Puts is the problem. Function arguments many, that's not the problem. That's something known. What did I just copy and paste? Integer. Okay, so putchar returns void. Should help us out. And again, in the future, I didn't need to run the test again. In the future, we can retain the return type, right? This is only temporary. In the future, we can retain the integer return type and then actually give it an attribute of discardable. And then that means that these errors won't happen. Multi-line string. I'm good at that. Overload block, weird byte array, pointer subscripting. Interesting. What's going on here? Let's put char again. String type inference and while. Infer this. I like leaving little gems like that for myself. String type inference. Infer this. That's such a meaningful statement. While, that's right. This was like one of the first tests I got working. Yeah, this is looking better. Not so many things failing now. That's a PogChamp. Hey, we're back to just the 5 out of 94. I think I could do something like this. Yeah. So we'll see how this works. This is basically running the test suite, but also with an optimized version of every test being tested. So it's also testing the optimizer and seeing if it breaks any programs, right? It takes a lot longer, as you can see, which is why I generally don't do this. There we go. So you can see that it looks like there should be 10 failing, but we have 12. So we have bug with not or something when optimized. That's broken. Function arguments many. Lots of phi nodes. Overload block. Overload ref in call, but only when optimized. So optimization is breaking overloads ref in call. That's an interesting one. And then we have passing weird byte array and return array. So this is normal. This is normal. But this and this are not supposed to be there. Not too bad. Something to think about. Infer this, type that, compile all, gems everywhere. Temwile. Oh. Samuka Fritas, thank you so much for the follow. Let's turn that off. Get our quick tests. Hello, hello. Thank you for the wave, Samuka. If you are new around here, be sure to join the Discord for announcements every time I go live. Ask to join the notifs group and you'll be notified. You'll be pinged, ding ding, every time I go live. Do you want that? Come join, come ask. We have a fun time. You can get help with anything you're working on. This is mostly me begging for knowledge and not really. You can just post stuff that you want to show off about. You can ask about linguistics and language. We got a lot. We got a lot. Anything in general, as long as it's programming related. Cool. Now we still got the 5 tests. But yeah, be sure to join the Discord. You will never miss another thing. Just like Sam Dev joined the Discord. Thank you so much, Sam. It's good to see you. I think I already hit limit of 100 Discord servers. Did ya? I'm pretty far off from that limit. I don't know if you noticed. I am pretty far off from that limit. Mr. Mugume says no JavaScript questions. I mean, you can ask them, we're just not going to answer them because we don't know JavaScript around here. Yeah, we need to, yeah. So instead of using the function return type, we need to figure out, is the callee a function type? If so, we can use it as a node. But if the callee isn't a function type, which is likely that it's not, it's likely a function reference, then we need to follow the function reference until we get to the function node, which is what this says. Timwale says they want me to pay Nitro. I mean, don't, if you want my advice. I don't pay for Nitro. I just have one server. Because this community has everything I need. It's an amazing community. It truly is. That's cool. So now we've enforced no discardable. Not no discardable, no discard by default. Cool. I think we can... Oh, I didn't commit anything ever. Remember that? I have such bad ADD. Remember when I was doing that? Okay, let's think about this. And then we have the new keyword that we want. Yes. Discard that hunk. We don't need a new line. We want the actual return keyword. Yes, please. And up the token count for the static assert. And also add it to the function. Mr. Mugabe, he communicates with his family through RFCs. Request for comment. I'd like some milk from the store. Could you get it to me by next Wednesday? Thanks. Oh. Lexer. Return token. And now we're going to go with, this is going to be a lot of changes because we're creating a new AST node, and that kind of bumbles out through the whole program, sadly. And we're also adding node counts everywhere, which is really nice, I think. Pop those two. Not sure where I ended up. Pop the top one. We definitely want to be able to print return nodes. And we would like to static assert that there are 17 nodes currently. Cool, all of AST.c. We also want static assert node count here. We're not going to do that yet. We're not going to do CodeGen yet. We're going to keep it at the parsing level. So we're going to parse token return into one of these things. What else did I change? Let's think about this. That's the tutorial I'm working on. CodeGen, IR. I did have to fix that bug in IR. I'll have to do that. I just removed an empty line, apparently. Molly the man says, hello, we have return now? Pog. We do have return now. We even have tests for it. So for example, here we have foo, where we return 69, and then 42, which is what normally would be returned, right? And then we call foo, and this returns 69. It's a passing test. It's PogChamp. Okay, let's think about what we actually need to do here. Node return type checking, that's not parsing. I think I've included all of the parsing that is needed. Parser. Return node. Molly the man W. Yee. Let's go! Okay, type checking. Now we don't want to include our little change we just did, which is the no discard enforcement. We would like to just type check return. PogChamp, okay. And do I need anything here? Func equals parent, return, everything should be fine there. Nothing else in the type checker. We have my experimentation in the back end. We shouldn't worry about anything like that. Don't quote me on that, by the way. Do not quote me on that. A little sus. Oh, God. So this is going to be SEMA for semantic analysis, and we now semantically analyze returns. Type check return nodes. Molly the man. Sus! Sus guy. Yeah, I'm gonna fix this little bug in IR right now, just so it works. I'm gonna say IR fix bug in removal of entire blocks, basic blocks. Since an instruction mustn't be used when it is removed, we must remove instructions in reverse order. That way the later instructions that rely upon the earlier ones get removed first, and the earlier uses are no longer. Cool. Cool, cool. And now that's the discardable stuff. Now it should just be code gen. Pretty simple. Generate code for return node. That's kind of fun, huh? That is very fun. And where are we at now? Where are we at now? Can update the to-do. When do we start to rewrite the compiler in itself? I mean, whenever you're ready. Feel free to. We're not going to rewrite the compiler in itself, but we will write an intercept compiler in intercept. Hopefully that makes sense. Molly the Man says next year. I mean, you can start at any time. There's nothing stopping anybody, right? So we should have everything we need for early return a fag. Yep, we should have everything we need. Molly the Man says, when we write the core lib, we can rewrite it, or standard. I mean, the standard is definitely going to be separate from a compiler, because we want any compiler, intercept compiler, to be able to use the intercept standard implementation that we write. Tests. Tests. Early return. We did it. Yeah, of course I meant we can rewrite the compiler when we write the standard or the core lib. Yeah, maybe. Standard is core, by the way. You just have standard. That's an interesting one, Molly the Man. I can't type. You can type something. That was fun to say, too. Okay, we did it. We have early return. I'm going to push that stuff to intercept. Perfectness. And then that is now live. You can go to the links down below, wherever you are used to getting them, and test out this new early return. How about that? There's no example yet, but there is a test. What do we need? What do we need? Bitstream says you can make core lib while writing a compiler. Just write a compiler and extract common stuff into standard lib. Easy, 5-head, 200 IQ. Exactly. Easy. Okay, so now let's do this thing. And then we're just gonna change all those. right away just going to start mentioning technically all of the tests that had external functions, return type changed to void, should in the future, once implemented, use the discardable attribute, function attribute. Sema, enforce no discard for non-void returning functions. Yeah, for functions returning non-void by default? Sure. Very good. Molly the Man, we want include or import. Nico CS, thank you so much for the follow. We are working on import. Got that GNU documentation style, right? Molly the Man says, is it hashtag import? Sorry, I just had to answer a text. It was probably silent a little bit. Is it hashtag import? Sort of. Tests. Ensure no discard is the default for non-void returning functions. Cool. And this test as well. Bitstream, honestly, compiling programs like cat standard.int, program.int, piped into intc, reading from standard.int is the only Chad way. No imports or includes needed. Register allocation failure case. Alrighty, those should help a lot. Cool. This is the tutorial docs. These are examples. That's right, that's the integer type fix-up. I may want to... I do have to go very soon, just so everybody knows. Be sure to click that follow button and join the Discord if you really want to be notified next time I go live. Ooh, join the Discord just like Temwile and SamDev have today. Thank you so much, guys. It's great to have you part of the community. What was I looking at in the x86-64 backend? Why was that relevant? I don't remember. I was just looking at Git and thinking about... What was I just thinking about? Failure allocation, no discard. SDL2, that's right. The MSWin thing. Handle argument on the stack that is not lowered to a pointer. I'll get into this next stream. I don't have time right now, sadly. Do you have two Emacs opened, or it's Emacs client for ERC? It's one Emacs. There's 2 frames. So this is the Emacs window, as you can see, and it's just in OBS. First time chat from Anj asking for the project, and the immediate link from Molly the Man. What a legend, Molly. Linking it right away. Trashboat Kai, thank you so much for the follow. I appreciate it. Be sure to check out all them links. But yeah, not all arguments passed on the stack are lowered to pointers, but that's what we are assuming has happened here. And that's definitely not what has happened. So we need to just basically check if it's an aggregate and do this if that's the case. But if it's not an aggregate, all we actually have to do is where is it? Sub from the base, sub from the stack pointer. Not even sub from the stack pointer, right? Yeah, we just have to store the actual value onto the stack. Bitstream Molly the bot. Lamau. He just intercepted the bot message and did a man in the middle. My stream is being hacked by Molly. He's so fast. Insane streamer gets hacked live. Oh. I'm so dumb. Okay. Anyways, that has been, we added early return to the compiler. As you can see, we can now actually, hopefully somewhere here, optimization or not, we can now actually get a return node in the AST that has an optional expression, and it generates a proper basic block that works properly with everything and with control flow and everything in the IR, which means that we end up returning 69 when we say return 69. Thanks for joining us today. If you haven't, be sure to if you haven't already, join the Discord. We have a fun time. Gmos asking for the notifs roll. Gmos gets it. We got that notifs roll rolling out. It is, everyone can have it. Everyone can have it. Just gotta ask. Molly the Man says, I'm Gmos. Oh, that's Molly. What's up, Molly? It's great to have you. I am glad you have decided to join the ultra exclusive notification club. Thank you everybody so much for watching. Ang says, ugh, text files in GitHub are awful with lines not breaking. That's super true. Bitstream says, face reveal. Oh. Be sure to check out the GitHub, the project we worked on today. I also work on an OS. That's a lot of fun. I work on that here as well, so be sure to stay tuned if you're interested in that. And check out my YouTube for all my previous videos on the Lenser OS, on the compiler, and I've done some other little projects here and there, like the implementing float by hand. But yeah, I've done a ton of stuff. I've done a ton of stuff. Be sure to check them out, and all the VODs are there. So if you want to watch all 8 days of me coding this compiler, it's there. What's up, Zora? What's up? Tumwile says, are you coding secretly? That would be really funny. I'm not. I am not. I have bad ideas. I'm so glad. Anj, welcome to the Discord. It's so good to have you. Thank you for joining. We appreciate you. Welcome to this glorious community, and we hope you have fun within it, Mr. Botka. But yeah, be sure to stay tuned. I do have to go for now. I am busy tonight, so I have to get ready. I should be able to stream tomorrow. And it should be able to be a longer one. I should have way more time. Yeah, tomorrow's Thursday. But yeah, so come back in like 24 hours. I'll be streaming for way longer. And we'll be having the same chill fun. Anj says, not exactly a fan of the Lang initially, but the topic is fun. Big Pascal vibes. Thank you. I appreciate it, Anj. Thank you for the follow as well. Crouch says, oh 07. Bye, Crouch. Bye-bye. Ta-da. I gotta change this. Goodbye. Bye, everybody. I'll see you next time. Keep it real. Check out the YouTube. Click the buttons. All the links. Check them out. Just see what's there. Or just click them for fun. Bye, everybody. Love y'all.